All right, so now for this problem, this is easier than you think. They want us to take the derivative of the inverse function of f of x, okay, and then evaluate it at x equals 3. All right, so here's the thing. This is the same as 5x squared is equal to y. To take the inverse, I swap the x and y. Now, then I would solve for y, so I would say x divided by 5 is equal to y squared, and then I would take the plus or minus square root of y. Okay, and that's why they wrote down there that x should be greater than or equal to 0. So then if x is greater than or equal to 0, my answer will always be positive, blah, 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 blah. Now I need to take the derivative of this. So this is f inverse, which is x over 5, or the square root of that, which is really x over 5 raised to the 1/2. Okay, does that make sense? All right. So now to take the derivative of that with respect to x, I'm just going to toss the 1/2 to the front, and then have the stuff on the inside remain the same, raised to the negative 1/2, tack on the derivative of the stuff on the inside, which is 1/5. Now, if I clean that up, I've got 1 over 10. And then this goes on the bottom. So that's really the square root of x over 5 on the bottom. And I think that's it. And we could clean it up if we wanted to. And what we're asked to do is evaluate this at x equals 3. Okay? Why do I feel like I'm writing some? So I've got x divided by 5, then you take the square root. Oh, it's not x equals 3. It says that f of a equals x. Okay? And then we say that a equals 3. So we're saying that f of 3 is equal to our x value. That's what we need to plug in. So if I were to plug in a equals 3, because it is the inverse, instead of plugging in the x, I would plug in the y. So I think it would be 45, right? Because over here, if I were to evaluate this at 3, then that becomes 9, and then that becomes 45. And then when I plug this in, I got 1 over 10. Well, we're running out of room. Let me write this down. Because this is the inverse function, remember that my function f makes x into y, but the inverse takes y and makes it into x. So if I wanted to evaluate my derivative, which my derivative of my inverse function, which is 1 over 10 times the square root of x over 5. If they say a equals 3, f of a equals x, what I'm supposed to do, because we're evaluating the inverse, I'm supposed to take the 3, plug it into f of x. And that means that I'm going to evaluate 45. In other words, I'm going to calculate this expression at x equals 45, which would be 45 over 5, like that. Okay? Okay. So now that's going to give me 1 over, this is going to be the square root of 9, which is 3, or 1 over 30.